welcome to our session following with Paul. Let me introduce you to him. He will give us a talk about the Internet of Things, which is one of the most important topics currently. Pretty interesting. Let's see what he will have to tell us. He's coming from grandcentrix, which is a company recently bought by Vodafone, and he's the VP of Sales. So please welcome Paul.
Thank you very much. Thank you very much. Good morning, everybody. The microphone seems to work. We established the clicker doesn't work, so Jimmy at the back will be moving my slides forward. Jimmy, if we could jump one slide already. Yep, so my name's Paul Haigh. I'm an Anglo-Bavarian, as I just said to somebody in the foyer, which means originally from the UK, but in Munich for the last 20 years. And I've been involved in IoT for around 20 years as well. So the last 10 years within Vodafone IoT itself, and just recently, as we acquired grandcentrix about a year ago, I've moved into grandcentrix, which is really exciting. So I'm actually going to cover about 3 blocks in my session today, which was originally planned for 15 minutes. I'm told we've got 30, so I can do it a bit slower than I was expecting, but hopefully cover the ground quite well, which is quite nice. So 3 blocks basically. Who are Vodafone in IoT and grandcentrix, just relatively swiftly. Something about end-to-end IoT and actually connecting products. And then a little bit at the end really about new network technologies which are emerging and how we're using those. So I think this session's really interesting for somebody who's interested in bringing a physical product into the world of the Internet of Things. That's really kind of our core topic, I'd say, at grandcentrix. But first off, if we move to my first slide, why bother? Why do IoT at all? And about 18 years ago, I was sitting with some engineers and executives from I don't want to give the name away, but a large automotive company based in Munich, and the feedback was, why would you connect a car, Mr. Haigh? It's too expensive, and can't really understand why you'd want to do that. I mean, even back then there were some. Of course, there's some ideas about why you might want to connect a car. But the point I want to make is that we all know in the last 18 years, the idea of a car not being connected is faintly ridiculous. And if we look at, the advantages of such a product being online in terms of safety, if you have a crash, the eCall type of systems where the emergency services are immediately informed. We're looking at entertainment systems. We're looking at keeping the car updated, getting software updates, and of course Tesla and Elon Musk have been doing a lot of good publicity around that kind of feature. A couple of years ago there was a hurricane, and Tesla did an over-the-air update to the range of the cars so that people could flee the hurricane. Whether it actually worked technically as well as they explained, I'm not sure, but it was certainly a hell of a marketing message and was based on IoT technology. Of course, the whole topic of global warming and environmental topics is relevant for all companies at the moment, and IoT is a good basis to improve the environmental footprint of a lot of B2B processes, I would say, because if you can avoid that journey that doesn't have to be taken to check something or install some software, etc., that's obviously a no-brainer environmentally. And we as Vodafone, we do a regular audit of how many tons of CO2 have been saved by our own use of IoT technology around energy management, etc. And of course, last but not least, is the whole business of business models and what can be thought up for new service models, etc., which are based on this new technology. And over the years, when I've been at such conferences, the whole topic of business models has been highly interesting to a lot of people. And of course, the business model improvement or the new business model is highly specific depending on your topic of business. But let's say it like this: if you can find the sweet spot to leverage this technology, then I think it's really exciting. what can be achieved. And of course, going back to the car example, we see that in terms of switching on and off features, streaming entertainment services, etc. So products become revenue generators. They generate recurring revenue. So instead of shipping a box and forgetting the box, essentially, a manufacturer has a relationship with this product going forward. Can we move to the next slide, please? So a little bit about grandcentrix. It's been around since 2009. Just over 200 people, mostly engineers. There's one or two salespeople like me and management, but that's it. So about 180 engineers from the 200. It's quite impressive, I think. Based in Cologne and Dortmund. And we were bought by Vodafone at the end of 2019 to enable Vodafone to do end-to-end IoT, primarily with focus on the German market, but also to leverage that globally. I'll come to that in a second. Maybe we can jump to the next slide. There's Vodafone. A lot of people know Vodafone as a communications provider associated with handies. Don't know that we're actually world number one in IoT, and have about 1,400 people worldwide who work on IoT, and globally ranked as number one by Gartner regarding IoT. And if we can jump to the next slide, I just want to quickly go through these, covering a hell of a lot of countries. Yeah, I mean, IoT is a massive topic, and I think if we can just move on to the one last slide quickly there. These are the kind of areas that get covered. We've actually bought a lot of companies to cover a lot of verticals. So we've got specialists in health, for example, and health solutions. We've got building technology. We've got agriculture covered by specialisms. And we at grandcentrix, I should have mentioned automotive, of course, a massive organization in Varese, which has been bought by Vodafone. But we at grandcentrix are the industrial center of competence. So it's quite nice that we're sitting here in Germany, and it's our focus to bring products, physical products, into the Internet of Things. But needless to say, there's a lot of other stuff in the cupboard which is, useful to us in fulfilling that mission. Let's say it like that. So, Jimmy, if you could move forward one slide. So this is the end-to-end IoT chain, and of course, with a group of people like we have today, there'll be one or two of you are sitting here as absolute experts in this area, and other people, mildly curious and perhaps producing products and interested to learn a little bit more. So bear with me as I try and work out how to position what I'm talking about here and how I explain it. But on the left-hand side of the chain, we see. I should stay here. I've been told earlier on. Otherwise, thanks. On the left-hand side of the picture, we see a product, and I've chosen a bed deliberately because hospital beds are a project at grandcentrix at the moment. So networking hospital beds, which just goes a little way to show the diversity of products. I mean, there's a huge range of products that can be networked, and a lot of them you'll know, but some of them probably never have thought of. Hospital beds is, I think it's an interesting topic. But what do we do when we want to network a hospital bed? And I deliberately brought this chair out earlier on because our role at grandcentrix is that we literally take a physical product like a chair, or I was in the office in Cologne last week, and a huge air conditioning unit was delivered on a pallet into our offices. By the way, we're having to get a hanger to take all these things. So we get physical products delivered to us quite often. And what we do is essentially show that this can be connected and how it can be connected. And not only then show it, but then take the whole process through to an industrial and mass rollout solution. So if we imagine somebody wants to network this chair to enable them to tell whether it's being sat on or not, for example, or where it is, then of course some sensors need to be built into this product, because this is not an electronic product. Other products have sensors in them already. They already gather data and if you can physically interrogate them and find information about them, of course, but other things have nothing in them at all. And so we're looking at putting basic sensors into a product and then putting it in a position where it can communicate. And this is a whole kind of large topic around hardware and embedded software, which is often the sticking point in IoT projects. Because over the years, networks have existed, cellular networks have existed, there's been Zigbee and all possible Bluetooths and et cetera, but what's actually quite tricky is getting the right piece of hardware into a physical product. So we've got about 60 or 70 engineers, the tendency is growing, who are focused on the whole area of getting the right piece of transmission hardware into a physical product. And I'm going to talk to you in a second about the different network technologies which can be used, or what's kind of in fashion. I said the modern way to do IoT earlier on, and I'll talk to you about low power wide area in a second. But having established a connectivity with the right transmission device, we're looking at the data being sent through a cloud to a cloud and landing in the customer cloud in the right format. So we at grandcentrix are able to do this complete end-to-end piece. Often customers say to us, well, you know, look, we've got our own cloud already, we don't need anything from you, but we actually bring together all of the components to set up this end-to-end chain. So if we go back to my example with a chair, just because it was here, you know, we've put in sensors into the chair, we've put in transmission hardware into the chair, it's sending its data from wherever. By the way, it could be sitting in you know, Turkey or wherever in the world, and send its data through a global network. And then we're looking at having the software backends in place in order to determine, you know, where the chair is, what's happening with the chair. And if my business is renting office space, you know, this is highly relevant, because I can say, look, if you want to turn up in this office here, you'll find that chair there is free and available for the next 5 hours, for example. That would be a business model which is built on top of this technology. I'd like to ask you if there are any questions, but I think I'm not allowed to. We have to wait for a session later on. But so that's a kind of a run through of an end-to-end chain. Maybe a little bit about network technologies. Jim, if you can jump to the other slide, the next slide. You're all familiar with 2G, 3G, 4G, 5G, etc. I'm not sure how familiar you are with the low power wide area networks, and I think they're quite interesting for somebody like me who's in the IoT world, at least, because LTE or 4G is kind of the basis of mobile phone technology, cellular technology at the moment. Of course, 5G's been added to it, but that's a kind of a build on top of fourth generation. And low power wide area is something which is essentially a software update within the LTE network, within the 4G networks, which has been going online since about summer of last year. Here in Germany, it was around September, October that both Vodafone and Deutsche Telekom switched on the low power wide area networks. And as you can see from my picture here, these different networks are kind of perfect for running different applications within IoT. So on the left-hand side, we've got data-heavy things like surveillance cameras, connected cars. You can imagine how many gigabytes of data cars are generating. The forecasts, by the way, are enormous. If we think about the whole self-driving piece and the kind of the data volumes that are required going forward, they're quite enormous. But other things like cameras, etc., relative data heavy. So what you have there is a network which can support that. But of course, the whole hardware piece, for example, is very energy intensive, very computing intensive, and quite expensive. So that fits to a expensive asset like a car, for example. But moving over these two new networks, which is LTE-M and narrowband IoT, which are kind of a subset of LTE, are optimized for other devices. And LTE-M is kind of in the middle, and it's kind of for relatively data-intensive devices. And I've got here cars, vending machines, security systems. You can actually do voice with LTE-M, which is relevant because 2G, by the way, is being switched off. And 2G has been used for voice over the last years. Switzerland's already switched it off as an environmental policy to save energy. I know there's some Swiss in the room. And of course, that's happening as well. 2G, it's still running at the moment in Germany, but will be soon gone. So LTE-M will support a bunch of IoT applications in the middle. What's really interesting, I think, is also on the left-hand side, narrowband IoT, which is an interesting technology which uses very little energy, but has a very good penetration through buildings because of the frequencies that they're used. They're quite long wave frequencies, so you'll know, if you remember your physics, that long waves are good because they go a long way, and they go through things quite well, but they don't carry so much data as other waves do. And so narrowband has certain limitations, but also plus points, because what we have suddenly is a public network technology which doesn't use much energy and can have relatively cheap hardware, because differently from the things you put in cars to run 5G, the kind of the processing power, the chip power required, and therefore the energy and the cost of the chip itself is much lower. And why is this interesting? Why is this point interesting? Well, think how much a chair costs. I don't know, maybe 200 euros. You can't have a 500 euro modem fitted to a 200 euro chair. Maybe it works if it's 5 euros or 10 euros, but certainly not hundreds of euros or even tens of euros. So in terms of getting the adoption of IoT to kind of work anywhere IoT, which you might need in your products. I don't know if somebody was here from Chibo earlier on, if it's a coffee machine, if it's a piece of furniture, if it's lots of things that require these lower price points to be connected into the Internet of Things, then narrowband is the perfect choice, and it's becoming much more widely available. I think Vodafone covers already 40 countries, often with a couple of networks in the country available. So the question of availability is not so critical as it was maybe 6 months ago. And also, as I said, that the hardware prices are going in the right direction. And we at grandcentrix are currently working together with Sony on a very interesting, Sony Semiconductor Israel, on a very interesting packet tracker. It's essentially a two-dimensional label, which is a cellular device. It just gets stuck on a box. The box gets sent somewhere, and this device can stay live for around 18 months and send messages where it is. And that's all possible because it's running on a public network, so the networks are everywhere. It wouldn't work if it was just Bluetooth and somebody had to stand next to it with a handy, as we call them here, or mobile phone. It works on a public network, and it can tell people where it is, and it can stay alive for 18 months, 2 years, because it doesn't use very much energy. So it can use a very, very thin battery and tell us where it is. And that's on the market probably sometime next year, and is for me, perfect example of really IoT moving away from, 100,000 euro BMW, which is nice, but in a way kind of frustratingly limited to, an everyday item, which can suddenly talk and send us information, and we can use that information. And I think one other thing to mention with this kind of technology is you don't need a gateway for it. So thinking back to the hospital bed, one of the problems which our customer in that area has encountered in the past is that hospitals are not happy to have you going through them, screwing kind of transmission gateways onto the roof to say, look, we're going to collect the data from our bed. Don't mind us. We're just installing something here on your ceiling. Of course, that's not an option. So a lot of things have relied on local networks in the past. That means they sent the data to a router, which was in the building, and then the router sent the data away. This is all stuff which can send the data from itself. So in other words, the chair gets put in a building somewhere, and it doesn't need any other infrastructure. Yeah, it just sends its owner, or the business model owner, the data out. So, Jimmy, if we can jump to the next slide. Yeah, there's just a, I find it quite interesting a little bit about the propagation, wave propagation of the different network technologies. And as you can see, you've got with 4G there, a sort of relatively short range because it has to transmit a lot of data, so it's relatively high frequency. But these lower frequency or longer bandwidth radio, for example, narrowband IoT, goes a lot further and it goes a lot deeper. So you can take these devices down into the cellar, our chair, for my example, take it into the cellar, it will still work. And it's already, it's a little bit like magic, isn't it? Mobile networks in a way, and people don't believe it. So we actually do have some network sensors which I take with me. Normally, if I'm having customer meetings, it's been a bit difficult over the last 18 months, but go into the cellar, you can show that the network is actually available, because people often don't really believe it, but it's true. These networks are in your cellar today and usable, and not being used that much at the moment, to be honest. So let's maybe flip on to the almost last slide. Oh, no, yeah, something about how we work. I mean, there's a very good talk earlier on from T-Systems about agile and making the whole organization more agile. Respect to those ladies. That sounds like a tough job at T-Systems. But yeah, I mean, we of course work in a sprint-based way with our customers in order to go from a chair which doesn't send any data at all into a connected chair which can be produced en masse. And I think we've got a couple of slides about reference projects just to give you a feel about who's doing what. These are all German kind of Mittelstand examples. We've got our hospital bed on the left. That's the company called Stiegelmeier, who are launching a connected hospital bed using this low power wide area network. We have Bega, who you may or may not have heard of, but it's one of those sort of hidden German champions based up near Dortmund, and actually did all of the lighting in the Apple headquarters in the US just recently, and for who has decided to use narrowband IoT technology to switch lighting systems on and off. And if you think about it, you can, if you switch them off using that kind of technology, you save a lot of wiring. So the whole business of street lights and lights in buildings, you can make controlling them much easier if you can simply talk to the lights. So you have one software system, you can say switch off all of the lights in the second floor, or on all of the lights in a certain part of the city, and you don't need the physical switch gear which you might have had in the past. Mennekes, this is all around electrical boxes, which is particularly relevant for a new generation of wall chargers, which are rapidly appearing in people's garages at the moment. Yeah, air conditioning systems. That's not the company who sent us the massive pallet the other day, but is another example of a company bringing in their HVAC systems online. And last but not least in that list, somebody who's doing roof monitoring can actually report the status of roofing systems and that they're not leaking, for example. Because sometimes the infrastructure is so expensive and it's so critical that it actually is proven to be working. It's more efficient to monitor it 24/7 and send the data 24/7 than to wait for something to go wrong. And yeah, I think that's. I've had some very interesting meetings by German companies that have built things, sometimes in America, and somebody's done some very bad maintenance somehow, the whole system has blown up, which has cost millions. And unless you can prove that somebody's done the wrong maintenance, then you have a problem. IoT, I think there's another kind of, it's not very sexy, but build it into products to prove that they weren't misused is also a very sensible use of the technology. And this is really the last slide, I believe. The next one is that's just a list of companies who we have worked for in the past and currently doing all sorts of cool stuff. I mean, I've focused a lot on cellular technologies, as I've used my chair example today, but we're specialists in Bluetooth, etc., etc. And Draeger, for example, they have a really interesting device in mines, which it kind of detects gases, poisonous gases, and also tells all the other devices in the area if somebody's walked into a pocket of gas, and we do all the kind of communication for them between the area. Knorr-Bremse, this is a pure data science, which we do for those guys. So lots of stuff to be done in IoT. It stays exciting, and it's been great to say a few words to you today. My first appearance saying something publicly for about 2 years, which is feels good to be out and about again. And look forward to having a chat with any of you at the table. We would have 3 minutes if anybody did have a question now. I'm happy to take it, but otherwise, see you at the table. Thank you.
Okay, thanks a lot, Paul. Thanks for giving us the introduction. I learned a lot about self-sending beds now, and I'm keen on seeing that in the next hospital I visit. We are now having a short break because in this room there will be no speech afterwards now. So please feel free to switch to the other streams, and at 12:15 you have the round table in order to get some questions and some chats with Paul.